Okay, today we are talking about the central limit theorem and how we can use that with means. So we're going to be applying a lot of the stuff that we talked about in chapter 6, but just doing it with sampling means instead, so larger groups. So we used z-values last chapter to find probability of an individual value being in a given interval. So remember, like if you took your ACT score and we knew the mean and the standard deviation of ACT scores, we could find what percentile you're in or the probability that you would get that ACT score. Now, if we don't have a normal distribution, if for some reason our population isn't normally distributed, we can do these large sampling distributions. Okay, so like we were talking about with the marathon, we put all these marathon runners on buses, and we do that over and over again. As long as our sample size is at least 30, then we know that the central limit theorem says we will get a normal curve, which means we can use our z tests that we did in chapter 6 with things that are not necessarily a normal curve, because we've kind of forced it into a normal curve. So, a couple formulas that we'll need. Remember, in chapter 6, we said that our z-score was x minus mu divided by sigma. When we're dealing with sample means, our z-score has to be adjusted slightly. It's x bar minus mu, so that's pretty much the same. But remember, sigma gets smaller. Our standard deviation gets smaller. So instead of just sigma, it's sigma divided by root n. So that's our adjusted z-score. So let's take a look at number 1. According to the Centers for Disease Control and Prevention, the CDC, the mean total cholesterol level for persons 20 years of age and older in the U.S. These years was 197 milligrams per, I don't remember what this stands for. That's the unit. Whatever. 197. So, what is the probability that a randomly selected adult from the population will have a total cholesterol level of less than 183? And we have a standard deviation of 35, and we're assuming that the population is normally distributed. Now, we're looking at a normal distribution. We know that the mean is 197. And we are looking at a randomly selected adult. This is an individual, just one person. So this is the stuff we did back in chapter 6. We want to know what's the probability that a randomly selected person is going to have a cholesterol of 183 or less. So 183 or less, okay? And since it's a randomly selected individual, we just use the normal z-score. So z is x minus mu over sigma. Okay, we do not need the adjusted one because we haven't taken a sampling mean. So our x is 183, mu is 197, and sigma is 35. So we put that into our calculator and we get negative 0.4. So that's our z-score. If you're doing this by hand, you would then need to go to the table because we want to know what's the probability, what's the area to the left of negative 0.4. So in the table we're looking for what's the probability that z is less than or equal to negative 0.4. And when we look that up on the table, let's see. Oh, you want negative 0.4 will give us 0.3446. Okay. Now, we also did these on the TIs, and if you do these on the TI calculators, that is totally fine. We are going to do normal CDF. Okay, and we don't actually need the z-score if you're going to use the calculator. So remember, you have your lower bound, which your lower bound is negative infinity. That was supposed to be an E. I don't know what happened there. Your upper bound, which is 183. Then it asks for mu, or mean, which is 197. And it asks for sigma, or standard deviation. So we plug that all into the calculator, and it also gives us 0.3446. Remember, there can be differences, slight differences between the table and your calculator, and that's okay. Okay, now we're going to look at part B. We want to know what the probability that a randomly selected sample of 150 adults from the population will have a mean total cholesterol of less than 183. So 183 we saw from the last one is a pretty low cholesterol. So this question is asking if we take 150 adults and we take the average of all their cholesterol, what's the probability that these 150 adults have an average that's that low? Okay, since this is a sample, we now need to use our adjusted z-scores. So we still have a normal distribution, 197, and we still want to know the probability that we're less than 183. But remember, this is 150 adults that we're talking about now. So to find our z-score, it's going to be x bar minus mu over sigma divided by root n. That's going to be in parentheses. So we get 183 that's our sample mean, minus mu, that's our population mean, divided by sigma was 35 over our sample size, which is 150 people. And when we put that all into our calculator, we get negative 4.90. So if that's our z-score, now we're going to go to the table, and we want to know what's the probability that z is less than or equal to negative 4.90. Now, if you're looking at the table, you're going to realize it does not even go that far down. The table doesn't go that far. It's practically 0. Okay, so it would be nearly impossible for us to take 150 adults and for them to have an average cholesterol that low. That would be highly unusual. Now, you can do this on your calculator as well. You're still going to do normal CDF. We're still going to go from negative infinity to 183. And our mu is still 197. Where the difference is here is our standard deviation is smaller because we have a sample of 150. So remember, we're taking all those means. Our distribution is going to get narrower. So you can put it in the calculator. So instead of 35, it's 35 divided by the square root of 150. And you can type it into the calculator exactly like that. The calculator will do the calculations correctly. When you plug this all in here, the calculator is going to give you an answer in scientific notation. I believe 0.000005. So it wasn't even on our table because it was so close to 0. The calculator will give you a little bit better estimate, but as you can see, that's teeny, teeny, tiny. So the likelihood of our 150 adults having an average cholesterol level of that low is going to be pretty rare. We will check out some more examples in our next video.